Okay, so this is kind of for my own reference for later down the road, but I guess if anybody else wants to watch this, they can. I was trying to figure out a way how to do defragmentation for Applied Energistics 2. I've only seen the YouTube videos for Applied Energistics 1, and they're really not that great. So this right now, after a few hours of thinking about it, is probably about the best way that I could think of doing it for my particular ME system. You could follow along with it, and it would probably work out just as good, if not better, or you could figure out a different way of doing it. But this is the smallest container that I could figure out, the smallest block by block size that I could figure out how to do this without, mix matching cables and getting crosstalk between cables and such. It's going to have ME, Applied Energistics 2, and Ender IO used in this particular setup, along with just basic Minecraft levers, on-off levers, which I'll probably link to some lights later so I can figure out if the lever's still on or not without having to look directly at the lever. Okay, so the left side, looking at this, the left side is handling drives. The right side is more so handling, drives as well, and data. So if you look at the front here, this is all your drives. For example, like my drive storage over here. Same kind of concept. This was actually one that I was toying with earlier. It is very simple, but it does not have the storage size required for something like this once you start storing a lot of data and you have a lot of drives that have used space. For example, like these guys. See, these have the used space. So if you had more than what this chest could hold in used storage drives, you wouldn't be able to process them. But the ME chest would be able to handle all of your empty drives, for example, in this array. So just looking at this is all cheated stuff just for testing and doing other stuff. So this entire data system, everything in here is all cheated. Just testing things for my real survival area and other players' survival area. So moving on, this is kind of easy to work with. You flip one of these two levers. Actually, you flip that one, it pulls all the empty drives out and puts it into the ME chest over here. And then you turn that lever off. You turn this one on, it sucks all the full drives into there. You flip that guy off, and then you flip this one on, it places all of the empty drives back into here. And all of your full drives are basically in this chest. Then you would flip this, and it would put all the full ones in here. It would start emptying all of data from those full drives through the ME cable into these drives. And then, of course, without needing to flip anything else, once the drives are empty that are in the MEIO port, it would place them back into your ME system. So your ME drives, basically. Problem with this is that with something like this, I have two dedicated networks. So my data network is all green, the green section here. So interfacing MEIO, or not MEIO, but Ender IO to this network would not work. It would require too much of a headache to get it, going. So, and also placing items back into the drives after they've been sorted. So I had to figure out a way on how to do this using my current setup, red and green. So having said that, some items can spawn here. Let's take care of that real quick. I was going to put a beacon back here for right now. That'll take care of mobs spawning back here. There we go. Okay, if you wanted to see that, that's F7. It'll show you where mods can potentially spawn. So I don't know. It's useful, yes. I'll put one back here just to make sure nothing spawns back here. Okay, so I had to think of a way to get it to work with my current setup. If I wanted to go larger than this, I definitely could. I could go much larger than this. More drives, more space, whatever. So I wanted to figure out a way to utilize the space properly. So if I wanted to collect a ton load of blocks, I could do it and not have to worry about adding more drives later. I could really go for a very long time like this, but why bother when I could go and sort it all so it makes it all, function better. So as it sits right now, all the levers, 1, 2, 3, 4, they all do a specific function, but they all work together. Basically, all the levers do is move drives. That's all they do. They only move drives. So really not that complicated. You don't need to mess with priorities like the other videos that you see on YouTube, the two other ones. You don't have to prioritize items at all. It's all lever based. So you flip one lever, you flip it off, la 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 la. Simple. The way the levers are seated right now, if they're forwards, they're off. If they're back towards me, back towards your player, they're on. So let's do this. Left side, we will pull this lever. This lever, and I'll make a diagram so I know how to do all this later. This lever here pulls the drives out that are empty, the empty drives. And how it's doing is this export bus. It has a filter for empty drives only. It has a redstone card set to active with signal and acceleration cards, because ME is very slow at extracting items. It's not supposed to do something like this in the heaping amount of time. So acceleration cards are needed. That will put that into this ME chest where I have some data by accident. This can all be ignored. So I could actually pull all of these out, which what I'll do is real quick, pull this drive out of here that has all the crap on it and put in a fresh, I'm not used to this panel yet, put in a fresh blank drive. So the only thing that will be in here is ME disks. Just to verify it's working, I'm going to place something in there. Cool. And I'm going to clear all this because we don't need that anymore. So, like I was saying, this is only going to hold empty drives. So we'll pull that lever, it'll pull all the drives out, put them in here. It'll hold them. Then we will pull this drive, this lever over here, which will activate this one, which it has a redstone card set to active with redstone signal, an empty ME drive, and a fuzzy card. And that is to match any. So basically all I'm just saying, pull anything that's an ME drive 64K. Doesn't matter if it has data on it or not, blah, blah, blah. Because when you pull that one, you will wait to release the drives back, and all that will be remained is the two drives or drives with data on them. So that will hold them. This I'm basically using this as a storage block for right now, which I will have to upgrade to a chest or something like that if I have more drives than what that could hold in full drives, basically. So this could be expanded to suit a bigger need. But we'll look at that later. Probably use a chest or a few chests, which wouldn't be that hard. All you would need to do is extract the drives that are in here to chests, and then the chests over to this. Or you could do it, whatever. However you wanted to do it. But for now, this is simple and it works, and I don't want to get too complicated. I've already been working on this for a little while. Okay. So once you pull all the full drives out into this, you will flip this lever here, which activates this export bus, which has a ME 64K drive with a redstone card, acceleration cards set to activate with signal. So basically all it's going to do is pull the drives that are in this guy. Well, they're not in here now because we haven't done anything, but any drives that are in here out into this, which will put it into your red network, which is your storage network, or your data network, or drive network. Let's just call it drive network for right now. It'll put all the green ones back in, all the empties, put them all back in. In that same token, when the ME IO port gets done processing drives, shipping all the data back to the drives that are on the full drives, this Ender IO conduit will put the empty drives back into your network after they're done. And that's done with this priority or this insert cable with the blue channel marked. Just basically, using blue to get away from green because green's already been used. So when we look at this, it only has a blue as an extraction color, always active. We don't have to send any item filters for this because there's not going to be any empty drives until ME IO port gets done processing the full drive. So once it kicks it over here as empty, this will automatically take them and put them back into our ME network, which is just fine. And it works pretty good, actually. So let's go ahead and try this out. I think I've covered everything. If not, I will add tooltips and basically cover it. This guy is only set with green as extract and activate with redstone signal, which activates by this lever here. And that just has, insert green. So I think that pretty much covered everything. Let's take a look. Yeah, I think we're good. Okay. So as it sits right now, we have all of this data in here. That's on these two top drives here. And I basically just copied those from those two over there, those full ones. So I didn't have to, spawn a whole bunch of data in here. All right, so let's flip this first one, which should pull all of the empty drives out, as it is doing. And that will place them in here, in your ME chest. You can only store ME chest data that has no, it can only store drives that have no data, or you can store items, but you cannot store drives that have data on them, which I thought was very weird, but it works. So now that everything's extracted, we will turn off the lever, which you can set up timers and such once you figure out how much time it takes to extract all your full drive or your empty drives, which would be fun to mess with. Okay, so now that all your full drives are, or your empty drives are extracted, we'll flip this lever. This lever, remember, will pull out all of the full drives. Anything basically not red necessarily. We could take, one of these over here that has barely any data on it, give it a copy and put it in here, and we could extract it with this. So if I add that, that has data on it, and it would not be matched by this lever. See, it's not matched because it has data on it. Even though it's green, it still has data. Okay, I'm going to take this out of the loop since we have a full set of drives in the ME storage chest. So we'll take that out for now. So once we flip this lever, it'll pull these out, and it places them in the ME interface for right now. Okay, and we'll flip that back off like I already done. So all the levers at this point should be off. Now, we need to put back in the empty drives so that the ME IO port can extract the data from the full drives to these drives in the proper way. So, defragmenting basically. So we do this by flipping this lever, which activates the export bus, which puts it into the interface and dumps them back in. Now you have two empty slots, which is because of those two full drives that we have sitting over here in the interface. So we're going to activate the interface now, which will use this to extract those drives over to here and put them in this first slot. I have acceleration cards, so this will go rather quickly. So we're going to flip that, it'll put them in, and it's starting to pull the data out, which you can watch over here on this screen. It's starting to put them all in here. Now it's done, basically. And it's adding some other things here. So as this gets done, we're going to flip this lever back off again. And it finished these drives. So I wasn't over here fast enough. We'll redo this, but it finished these two drives. So once it finished these, it put them over here, which this Ender IO took up and put it into this ME interface and dropped them back in. So now you have a full set of drives. Looking at this, you have a perfect set of drives that have the perfect amount of data on them. So for now, we're going to take two of these out. We're going to set them aside. And I'm going to come over here and grab my two other drives that have data on them. So, for example, these. Ooh, I don't want to take them out. I just want to copy them. So I want to make a copy of these back in. Okay, so these are drives that have data on them, but not are necessarily in red. So we're going to throw those in there now. So now we should have a lot more items in here. You can look at the tallies. You can pause the video between the two of them and look at the tallies. It's not going to be noticeable, but by the naked eye without pausing it. So we have drives in here that are not necessarily empty, but are green. So we're going to do the same format again. We're going to flip this on. I'm going to pull all the empty drives out. See how it's leaving these two guys in here? Because they're full. They have data on them. Not full, but they have data on them. 62 types and 10 types. So we're going to have them pull all of this out. Close that, because we don't need to see that. Okay, so now that it's pulled all the drives out, we're going to flip this off, and we're going to flip this one on, which will pull these full-ish drives out. and that places them in here. So, like I said before, you can overwhelm this because you don't have enough storage here, so you'll add a chest system over here that would hold all your full drives. Okay, so now that we've extracted, we need to put all of the empty drives back, so we shall flip this, and that will add them all back in. I don't understand why that is so much faster than the other one. I think I don't have where is it? I don't have acceleration cards. I think it's just because I have one of these matched. I don't know why it's much faster. I guess it's just, I don't know. It's weird. Okay. So now that we have all the drives over here that have data on them, we will flip this lever, which shall put them in here. Now you see how it's processing all of the data types. And we'll look over here. It's already put one drive back in, and it's still loading data back onto the drives. So we'll watch this for a second. And once it finishes this one, it shall kick it over here, and it gets sucked away back over to here. Now, if we look at these drives, you have 63, 62 of 63, 62 of 63, and 0. So remember that one drive had only 10. It had 10 item types. If we look back over here, it had 10 item types. Oops, wrong one. 10 item types. There it is. That is no longer the case because it has sorted these drives to be perfect. So if we take this block out, we should lose some drive space, or we should lose some items. Let's take this one out too. Okay, so I think what we lost there was 14K of something or other. If we put this back in. Yeah, 10K of nether iron and 12K of quartz. So if we pull this one back out, we won't have the 10K of quartz anymore. So it tries to utilize all the space available on the first drive to fill that item type before it moves on to the next. So you have a much more cleaner system, more user-friendly system basically. But you're not really going to notice this in normal gameplay if you have a lot of drives like this. The only reason for doing that is so that way you don't have a cluster mess of all these drives having data on it. Like, these drives over here could have data on it. You can pull that off, come back later, put the data back in, and those are already sequentially used, so it'll stick it, way over here, for example. It just kind of categorizes it all. So it should utilize this entire one and then jump to the next one in series, which ME is very weird about how they, put data on drives. In any event, that's how it's working so far. I will make another video once I figure out a better way of doing it without having, 4 levers. But 4 levers aren't really that bad once you get down the pattern. All right, I'll see you later.